Eugene, you've asked one among my favorite questions, and a surprisingly deep one. The essence of it is, how briskly are we actually moving? We are a solar system, we are planets going round the sun. But the sun has its own motion round the galaxy, the Milky Way. And there are larger motions still because the Milky Way galaxy is additionally moving through space. So I'm getting to attempt to break this down because there are a variety of various ways to think about motion, because once you get to those scales, one among the foremost important questions you have to ask is, motion compared to what? And I'll explain that as I'm going along. So one among the foremost easy to know motions, but a sort of mind-blowing one, is that the Sun is orbiting round the center of the Milky Way galaxy. Now, the Milky Way galaxy may be a huge collection of about 500 billion stars, and it's about 100,000 light-years across end to end. Now, we actually orbit round the center of the galaxy. The middle of the galaxy is about 30,000 light-years far away from us, and that we orbit around about once every 230 million years. Okay, that seems like an extended time. So 230 million years to form one orbit round the galaxy. So how briskly are we going? It seems that the Sun, and us with it, it's going at about 560,000 miles an hour. That's over half 1 million miles an hour just round the center of our galaxy. So immediately, you're moving at over half 1 million miles an hour round the center of the galaxy. And if you would like to believe it in a similar way, of a dramatic way, the middle of the galaxy has a massive region at the center, and it's about 4 million times the mass of the Sun. So immediately, you're orbiting a huge region at half 1 million miles an hour. That's quite fun. But there are larger velocities also. And here's where things start to urge a touch bit complicated, because the universe is expanding. And what that basically means is that space itself is expanding. It's not really correct to mention the galaxies are flying through the universe with the expansion of the universe. That's actually not how it works in the least. The galaxies they're in sense are standing still, but the space in between them is getting bigger. It's a very strange thing to believe, but the expansion of the universe isn't galaxies moving through empty space. And one among the explanations that this is often important is because the farther away you check out space, the more expanding space you look around. And it isn't that galaxies very distant are literally moving through space very, very fast. But they seem that thanks to us. There's something called the Hubble's constant, and what meaning is how briskly the universe is expanding for each amount of space that you simply look around. The Hubble's constant immediately is about 75 kilometers per second per megaparsec, and a megaparsec is about 3 million light-years. So that means every 3 million light-years you leave, things are receding from you at an additional 75 kilometers per second. So when you're 3 million light-years away, a galaxy would naturally recede far away from you at 75 kilometers per second. Now double that. Say that you're now 6 million light-years away, double 75, 150 kilometers per second. So for each 3 million light-years you leave, you set a further 75 kilometers per second onto the speed. Now, meaning the galaxies nearer to us aren't moving very quickly within the least in the natural expansion of the universe. But if you check out something billions of sunshine years away, you are looking through that much expanding space, and it are often receding far away from us, appearing to recede far away from us at a really fast velocity indeed. In fact, once you actually check out the very, very edges of the universe, things are receding away from us on the brink of the speed of sunshine. So that's nothing moving at the speed of sunshine. That's just the very fact that you are looking through that much expanding space that it appears to be going that fast far away from you, and this is often called the Hubble's law. It took an extended time for people to understand that there could be other motions besides just this expansion of the universe. And we need to tease them out because galaxies, as big as they're and as fast as they're Moving, the distances they're moving across are so vast it's extremely difficult to detect. Over time we realized that yes indeed there have been other motions besides this, what we call Hubble flow, this expansion of the universe. So we began to understand that the Milky Way galaxy was a part of larger clusters of galaxies. And in some cases, clusters of galaxies were bound together by gravity, kind of orbiting around big groups of galaxies. And in other cases, these concentrations of galaxies are likely to disperse over time because the universe expands. So ranging from relatively on the brink of us, the closest large galaxy to us is Andromeda. And Andromeda is so big then close that actually, we are falling towards one another faster than the universe expanding us away. Right now the Andromeda galaxy is coming at us at a speed of about 300,000 miles an hour. And that means that's getting to hit us during a couple billion years, so I would not worry that's not a drag for us in the least. And actually, we expect the Milky Way has collided with other galaxies within the past also. But the rationale Andromeda is coming toward us is that the force of gravity is accelerating us together faster than the expansion is taking it away. Other galaxies even closer to us are orbiting the Milky Way, just like the Magellanic Clouds. So now, let's leave a touch bit further and believe how the Milky Way is moving through space compared to larger things. Well, the most important motion we all know of immediately is that we are falling in towards something called the good attractor. And this is often a degree of mass, an enormous cluster of galaxies. And immediately, we're moving at a touch over 1.5 million miles an hour towards that a part of the sky. For an extended time, we actually didn't know what was there. We called it the good attractor because it seemed quite mysterious. But now, we realize that it's actually the middle of gravity of an enormous cluster of galaxies. Something called an excellent cluster. And this cluster probably contains over 100,000 galaxies, and it's probably on the order of about 500 million light-years across. And this has been discovered only within the previous couple of years, and it has been called the Laniakea Supercluster. Laniakea is the Hawaiian language word for the very best heaven. And this is often the most important group of galaxies that we expect that we are literally gravitationally associated with. We are literally falling in towards the middle of this giant collection of galaxies. So where's the sun going? How are we moving? It depends on with reference to what. We're traveling the galaxy at 1 million miles an hour. We're falling into the middle of a supercluster of galaxies at 1.5 million miles an hour. And all of that superimposed on top of the expansion of the universe, which isn't really a speed, it's just that you simply need to look around tons of expanding space. So there is no one answer on how briskly you're moving immediately. And I think that's one among the foremost wonderful things, is how complex these simple answers can get.